Morning class. We're starting our new unit, new topic called Inequalities. As a reminder, here are some notes on these inequality symbols. Here's a couple practice problems where you're graphing inequalities on number line. You're doing the opposite with these four problems. If I give you the graph on number line, can you come up with the inequality? You're going to do a bunch of solving afterwards, starting with these 6 problems. Then you have a little bit more solving as they get a bit more complicated. Alright, so you can work on those. First I have some notes for you. So these are the inequality symbols. You learned them a long time ago, maybe you've forgotten. Think about it like little alligators that always eat the bigger numbers, right? So this one is formally less than, or you can read it from tail first. Okay, read where the corner is. Like this part over here always points to a smaller number. So then this is less than, it points to the smaller number. This thing, an equal sign with a line through it, means not equal to. This thing, notice it has the alligator opening its mouth towards the bigger numbers, right? It's the greater than sign, or its tail's pointing out towards the smaller number and it's on the left. Okay, you read these symbols from left to right, this is the greater than symbol. And if it has a line underneath, that's the equal to part over here. So this top one is less than or equal to, and this one's greater than or equal to. And when we talk about inequalities, we can say that they could be true or false. Like for this one, if we were to start graphing it, you first draw your number line. Let's say 0 is over here, -6 is over here, right? Notice that here, right, 5 is bigger than 6. That's true. Okay, so that's part of it, the answer. But notice if I pick a number over here, like -10, is -10 greater than -6? That's false. But this one's true. 5. Notice it could also be 0 is greater than -6, right? That also works. So then that's an answer, that's an answer. When we have inequalities, we call them solution sets because there's more than one right answer here. It could be -5.99 over here, -1, +2, infinity, 100, so on and so forth. And all those numbers satisfies this inequality, or we can say that all those numbers are part of this inequality solution set. And to represent this on the number line, you draw it like so. Circle, then an arrow pointing a certain direction. Like that. Okay, and as I'm filling it in, notice that here I drew an open circle. Open circles means that you do not include that number, because -6 is not greater than -6. So you don't include the answer here, so it's an open bubble. And your textbook calls it a boundary point. You call it what you want. Boundary point sounds fancy. You're more than welcome to call it that. But this is what the graph of this inequality looks like. Key points to remember: open, circle here, and then it points towards all your other answers. For this one, we read it as x is less than +4. So there's 0, there's -4, here's +4. Open circle, since we don't include it there. Let's see, is 0, and then you can start testing out numbers. Is 0 less than +4? Yes, so that's why it goes this ways, like that. For 1c, we have y is not equal to 3, so that one would look like let's say 0 is here, positive 3 is here, negative 3 is here, every number that's not positive 3 would work here. So now you have arrows that extend both ways, because it could be -4, -5, -6, -7.1, or +2, +3, +4, infinity, so on and so forth. Okay, not equal to 3. This one here, y is less than 1/2. Start by drawing a number line. Y is less than 1/2 would look like. Find where 1/2 is. I always like to start with where 0 is. There's -1/2. Here's +1/2. So here we have our first instance of a closed circle, or closed-in dot, filled-in dot, because we do include the number -1/2 here. It's all numbers that are less than it, then your arrow points this way. For 1e, last problem we have, 5 2/3. If you're really lazy, you could just draw 0 and draw your other number 5 2/3. Most important part, it's a closed circle because it has the marking over here. X is greater than or equal to 5 2/3. So then you would go this way, all numbers bigger than 5 2/3. Okay, not so bad. As we remind ourselves how the inequalities work, this is how we graph the solution set. We start off simple with just one variable, and then tomorrow we'll work with 2 variables and how to graph those, or solving one of those. Thursday. Alright, so those are your first 4. Remember that I wanted to save some space, so I'm going to go over here. Now we do the opposite. When we have a number line and an inequality shown, can we work backwards? So in this case, we start where the dot is, the boundary value. We see that it has to deal with +1 somehow. We can call our variable x, and then we figure out, okay, is it this way or is it this way? And you can start testing some values. We know that 2 here is an answer, but then 2 has to be greater than or equal to 1. Nice, that's probably this one. Notice if I tested out 2 here, 2 is not less than or equal to 1. It can't be this one. So one way to approach these problems. More practice. Here we go. Here's +1. So you know it involves +1. Involves some number x, and you think, okay, does it go this way, or does it go, this way? I already made a mistake. Notice it's an empty circle, so it's not equal to. It's one of these 2 answers. So we see that 0 is part of the answer. So is 1 greater than 0? Or is 1 less than 0? We see that it has to be this one that's true, not this one down here. And you may have noticed that I switched the number and where my variable is. The order here doesn't matter as much. You could try either one. If you write it this way and you test it out, okay, notice it's this bottom one. Here's 2 ways to write your answer, your choice. But it does matter which way your inequality is opening. Notice the arrow here. The mouth is opening towards the 1 in both of these answers, and the tail is pointing towards the x. Third problem. Start with where the dot is. It's at 3. Has to deal with x. 0 has to be a part of its answer. So then it's all numbers less than 3. 3 is the bigger number here, and I include the equal sign. Or you could write it this way. Your choice. This one's a little bit more complicated, as you have two dots, so we can start with one of them. Here is -4. The arrow, think about it looking like this, going that ways. So it's all numbers bigger than -4. It's an open circle, so I don't have the little equal to sign. And x, right here, think about it like this. There's actually two inequalities hiding here. X has to be less than or equal to 2. I think tomorrow's lesson we will review these keywords ands and ors. When you have two inequalities, how do you put them together logically? Some people you may have also seen it written this way, okay? This is called a compound inequality. So there's two inequalities here put together. And it's a preview of tomorrow's lesson. Now we begin to solve inequalities. They work just like with equal signs, and you can approach these as if there was an equal sign here. So you can think about solving this equation for 3a. Subtract 3 from both sides. You have y equals 8. And then you go back in. You're like, okay, so replace equal with the original symbol. And you have your answer. Or just like change the sign in the first place, like for 3b. Leave that thing there, subtract 11 from both sides. Like before we were maintaining equality, now we're maintaining inequality. For 3b, our next step here is then divide by 3. Divide by 3. We have t is less than or equal to 7/3. That's how we solve. As long as we get our variable isolated by itself, we have solved the problem. 2a, just like with the equal signs, we need to combine like terms, isolate our variables. So first step is subtract y from both sides. We're left with y minus 10 is less than or equal to 6. Add 10 to both sides. Y is less than or equal to 16. We could sometimes be asked to graph these, in which case you can give the bare minimum. There's 0, there's 16, it's filled in, and it goes that way. Okay, so we're just focusing on the solving step right now. So here's an important note with 4a, okay? As you multiply or divide by a negative number, you have to switch your inequality sign. So here, right, multiply both sides by -4. Okay, switch the inequality sign. So when we multiply this thing, a by -4, a by -4, this thing has to swap. Now it becomes pointing this way. And that is our answer here. You can check, like let's say check, pick a number that's less than 24. Let's say a is equal to -25. So then -25 is less than -24. Check this first one up here. -25 divided by -4 is not yet 6, a little less than 6, 5 point something. 5 and 1/4, 525, is that less than 6? Yes. Okay. Notice that if you did not switch the inequality, you would have this answer, a is greater than negative 24. And suddenly when you pick a number here, like let's say 0, is because that's greater than 24, 0 divided by, wait, is that right? Yeah. 0 divided, oh, probably 0 is not the best option here. Wait, did I do that right? I forgot to switch it. That means I messed up my original answer. I like switched it. Where did I switch it? No, I messed up here. In my checking, this is 6.25, which is not true. Okay. So let's put that in red. Okay, I forgot to switch that first time I showed you my mistake. I have another instance to show you in 4C, so we can go there. When we're trying to solve and we have a fraction here, you can multiply everything by 3 first. Times 3 on both sides. So then we get 2/3 x times 3. And it's only when you multiply or divide by a negative number do you have to switch the sign. Like here, we leave the sign alone. Divide by 2, x is greater than or equal to 9. So in this example, we have that dividing by a negative number again, and this is where I can demonstrate the flipping. Okay, divide by -7, divide by -7. V is less than or equal to positive 115, right? But notice here, we have to switch the sign over. So really, this thing should be greater than or equal to 15. Okay, flip the sign. Flip the sign. More specifically, I need to flip the inequality sign. Because you are dividing or multiplying by a negative number. Okay, and let's say that we didn't, right? This answer is going to be wrong. It's the opposite of what you want. Because for this case, if you tried 0, which is less than 15, and you try it in your original, 7v is less than -105, 0 times anything is 0, 0 is actually greater than -105. It's not less than. So it's false. This is the wrong answer here. It's that opposite relationship when dealing with negatives that cause us to flip the sign. So that's as complicated as it will get. That's like the one new rule, I guess. Here, a little bit more solving. Subtract 12 from both sides. 3a is greater than 6, divide by 3, divide by 3. It's positive, so we don't need to flip anything. There's your answer. Subtract 6x, subtract 6x. 4x plus 5 is less than -15, minus 5, minus 5. 4x is less than -20. Divide by 4, divide by 4. To get our final answer of x is less than -5. Here, it may look intimidating at first, but you can get rid of both of these fractions by multiplying by 3. And when that happens, 3 times 1/3 makes 1. You're left with 3m plus 6. is less than 6m minus 9. Subtract 3. Now we can demonstrate the flipping again. Let's say I started with this step. Subtract 6m, we're left with negative 3m plus 6 is less than negative 9. Minus 6, that gives us negative 3m is less than negative 15. So here, when we divide by 3 on both sides, okay, flip, we have m is greater than now negative 5. Okay. Thinking, checking my work. Is it negative? Oops, should be positive. There we go, positive 5. My mistake. Last problem for today's lecture. A little bit more complicated. Maybe I'll distribute things out. Negative 6x minus 14 less than or equal to 3x. Distribute this, minus x minus 1. Combine like terms here. I'll also add this over. Negative 14 is less than or equal to 9x minus 1 is 8x minus 1. Add 1 to both sides, That gives us negative 13 is less than or equal to 8x. So your final answer here is x is less than, or, oops, keep the variable on the same side. Looks like this, negative 13 over 8. Or, as you simplify it, 1 and 5/8. And that's all for today.